Integration by part. Sometimes we have trouble deciding what's going to be u and what's going to be dv. Well, here's what we want. We want u prime to be easy to find, and we want the integral of dv to be easy to find. So that's the goal. And this is a little trick that might help. In most cases it will help, not all, but most cases. It's to use this acronym L I A T E, liate or liati. Okay, let me tell you what each letter stands for. L equals log function. That would be like log base 2 of 15, or the natural log of 7, etc. Then the I stands for inverse trig function. An example of inverse trig function, like arctan, let's see, we'll write tan inverse of x, or we could say arc sine of 1 over x, etc. The next letter is A. Now this is a tough one because it might be new to some of us. It's an algebraic function. And I'm just going to categorize the three basic algebraic functions. The first type of algebraic function would be a polynomial function. Example would be x to the second power, or you could get 3x to the fourth plus x to the third plus 1, that's a polynomial, etc. Another type of algebraic function is a rational function. I call them fractional functions because they are fractions, polynomial on the top, polynomial on the bottom, like 1 over x, that's a rational function. Another one might be x plus 2 over 2x cubed minus x squared plus 5. See, a rational function. It's just a fraction. And the last one would be the nth root of a polynomial. An example would be, let's say, the fifth root of x to the sixth minus 9x to the fourth plus 2, etc. So these all fall under the classification of algebraic. So we're at L-I-A. Now we're ready for T. T equals a trigonometric function. And we know what those look like. Example like the sine of x, the cosine of 3x, etc. And finally we have E, that stands for exponential function. Examples of exponential functions. We could have base e to the negative x power. We can have an arbitrary base 5 to like maybe the 3x power, etc. So that's the definition of LIATE. And the way you want to use this is you're going to choose u equals higher level function on the list, a higher level. And then dv would equal the lower level, or sometimes not on there at all. And the thing that's complicated about this is that sometimes the T and the E swap places as far as which one's a higher level and which is a lower level. That makes it more difficult. What I'm going to do is take the examples we've seen in class and try to choose the U and dV using this method. And remember, it's always about U prime being easy to calculate and the integral of dV being easy to calculate. So first we saw an example, and it was integral of x times the cosine of x, polynomial times a trig function. Okay, so this guy was algebraic because he's a polynomial. This guy was trigonometric. And if you look at the list, that would imply u equals the higher level. The higher level would be the algebraic function, so u equals x, and dv would equal the cosine of x, the trig function, dx. And that's what we did. That's how we chose them in the example. All right, another example we saw, the integral of x squared times the cosine of 3x dx. Again, we have the polynomial, that's an algebraic function. We have the cosine, that's a trig function. So u would be the higher one on the list of LIATE. So u is equal to the polynomial function x squared, the algebraic function, and dv is the trigonometric function cosine of 3x dx. Another example, we have the integral of the natural log of t dt. We did end up using integration by parts because it is not easy to integrate the natural log. So obviously we wouldn't choose that to be dv. It's obviously not easy to integrate. They wouldn't be asking us to do it here. So that implies u would be the higher one on the list, which is, well, it's the only choice because it's the only function, and it's definitely easier to integrate, to take the derivative than it is to integrate. So we let u equal natural log, and then dv would just be equal to dt. All right, another example. The integral of the arc tangent of 1 over x dx. And again, we only have one function here. And so we chose to let u equal arc tan of 1 over x. And then dv is dx. Now, that's the way it worked when we did the example in class. And let's see, that would be an inverse function. Inverse functions are pretty darn high on that list, so it makes sense that the functions that are higher on the list are easier to take the derivative, so it makes sense that we would call that the u value. And then later we saw, in later sections we saw this example, which is similar to one we already saw, the natural log of t squared plus 1 dt. Well, that's, again, the natural log function, which is the very top of the list of the easiest to integrate, to take the derivative of, So that's what we should call u, natural log of t squared plus 1. And the dv is dt. And finally, we have, well, this very strange example where we had the integral of x times the natural log of x over the square root of x squared minus 1 dx. And we broke it up. We actually broke it up in such a way that the natural log of x was separated, which is obviously the easier one to take the derivative of, and then what was left over was x over the square root of x squared minus 1. That is an algebraic function. So this one is a log, and this one is algebraic. Okay, so that would mean that we let u equal the natural log of x, and dv equals x over the square root of x squared minus 1 dx. And you should try to play with this on your homework and see how well it works for you there.